This lesson is Web API Fundamentals. The objectives for this lesson are to learn about what is a Web API, HTTP status codes and verbs, ASP.NET and its components that are used for building Web APIs, routes and endpoints, dependency injection and middleware, and the different design patterns you can use to create Web APIs. I do want to say one thing about this lesson. This lesson is all slides. Now, there's a lot of great background information in here that you will need, so I do encourage you to watch this lesson, and I do promise the other modules are mostly code, and they have much less slides in them. So a Web API stands for Web Application Programming Interface. It's basically just a set of routes that can be called from any application, sometimes called endpoints or even methods. We call these routes via the web using an HTTP protocol, and it makes our data that's behind our firewall accessible to people outside of our network. In this way, you get to only expose the data that you want. That data is then sent back to the caller as JSON or XML or even just plain strings. An example of a web API would be something like https pdsa.com/API/article. And if you were to type this into the browser, this one actually does work, you'll get a response back that is JSON. It's a JSON object where we have properties and a value like an article ID, and then 87 is the value. The magazine is code, the URL, etc. So this is what we get back from a web API call. That URL that we just saw can be submitted via JavaScript, jQuery, maybe Angular, maybe some sort of mobile app. That request is sent behind our firewall to the web server. That maps to a route, some sort of web API route like getArticle or just article. Then we get that data from somewhere. It could be SQL Server, it could be a MongoDB, it could be anything for some sort of data store. And then that response is sent back out to the calling program. Now, the web APIs should be RESTful. What does that mean? RESTful stands for Representational State Transfer. This means that the server does not know what state the client is in, and the client does not know what state the server is in. All the information needed for data transfer is sent with each call and sent back with each response. Now, routes or endpoints are simply a location on the website that contains the method that you wish to call to get the data back. So each route or endpoint can accept data or not. Could be just a simple call like the one I just showed you. They always return a status code, and they can return data with that status code as well. They don't have to. It could just be a status code that is sent back, indicating that something was successful. Most likely, data is returned with each call, however. So what is a status code? A status code is when we send a message from the server to the caller, and the code indicates if that call was successful or not. Now, there's 5 ranges of these HTTP status codes. 100 to 199 simply means, hey, I'm giving you some information about the call you just made. 200 to 299 is a success, which means the call was successful. 300 to 399 means that I got your call, but I'm redirecting your call to another method to finish the data that's going to come back for you, or a place where you can get the data. And then a 400 to a 499 is a client error, which means that however the call was sent, the data was not sent correctly or in a format that I understood on my server. So I'm sending you an error back saying you need to fix your call. Or a 500 to a 599 means, I'm sorry, but my server had an error. Something went wrong on my side, and I'm sending you this back so that you can contact me and figure out what is wrong at this point. Now, there are some common status codes that you're going to see more often than any others. 200, success. Hopefully you'll see that one all the time. 201, created. 204, no content. 400, bad request. And 404, not found. And hopefully you won't see this one too often, and that's a 500, which means something went wrong on the server side. Now we have what are called HTTP verbs, and each endpoint or route is typically a method that works on a piece of data. So think of a product, a customer, a work order, etc. So each of these are nouns, right? The actions or the verbs are the things that you want to do with those nouns. So I'm requesting a product, I'm requesting a customer, or I'm inserting a product, I'm inserting a customer. So a get verb means I'm going to retrieve one or more of some noun. Post, I'm going to insert. Put, I'm going to update. Patch is I'm just going to update a few properties or members of that noun, maybe not the whole product record, the whole customer record. I'm just going to send a few properties to update. And delete means I want to delete one of those products or customers or work orders. Now, with each of these verbs, we get typical status codes returned from each one of those. For example, for a get, if you're requesting something, hopefully you'll get a 200, but you may get a 404 because it's not found. Or a post, you typically get back a 201, or you could get back a 400 that there was some sort of bad request made. A put could be a 200, a 400, or a 404 if it didn't find that particular noun that you were searching for. Patch, also you'll get a 200, a 400, or a 404. And a delete, you typically get back a 204 or a 404. And we're going to see all these examples all throughout this course. To build web APIs, you need to have some sort of server and some sort of software running. We're going to be using ASP.NET, which is a free web framework from Microsoft that we can use to build either websites or web APIs. It runs under many different web servers, and there are two web API models that we can take advantage of. There's minimal web APIs, which are very much reduced complexity to get started. They're very easy to get started with. It's very similar to Node.js and Express if you've used those. We can also use the MVC model, which is a pattern-based method of development, and it's very fast, full-featured, enterprise type of development. So why should we use ASP.NET? Well, it's open source, which is great, so there's a lot of people helping to maintain it. It's cross-platform, so you can run it on almost any web server. It is one method for building web UIs and web APIs, which is nice because if you want to build a website then, we use ASP.NET as well. It has great integration with all the modern client-side frameworks, Angular, React, jQuery, mobile development, all those things can take advantage of the web APIs that we create on ASP.NET. It has built-in dependency injection, which we'll talk about and is very important. And it's very lightweight, high performance, has a great modular HTTP pipeline that we can tie into. So what can we build on ASP.NET? Well, we can build websites. We can use the popular MVC Design Pattern to do that. We can use Razor Pages, which is a page-focused approach. And if you've ever used web forms in ASP.NET, it's very similar to that. We can build web APIs. We can use minimal APIs or the MVC model. We can use Blazor, which is a framework for building interactive web UIs with C#. And we can also build SignalR, which are real-time communication type applications between clients and servers. So let's learn a little bit about the components that make up ASP.NET that we're going to use throughout this course. We have what are called routes, dependency injection, middleware. That includes things like logging and exception handling and security. We have model binding and validation. This is great for passing objects around and validating objects. We have CORS, cross-origin resource sharing, so we can have somebody outside of our firewall call our web server. And we have security. All these things are just built in to ASP.NET. Let's take a look at some of these in a little more detail. Let's take a look at routes and endpoints. Now, a route is the unique name that you use to access the endpoint. The endpoints are the methods that actually perform the action. So a route is passed on the URL. A single route can have multiple endpoints, and that depends on the HTTP verb. Now, get, post, put, delete, they would all map to this same exact URL here, the route. And each verb then is mapped to a different endpoint, a different method. Okay, that's part of that route. Conversely, you can also have a single endpoint that could be mapped to multiple routes as well. And we'll actually see an example of that later. Let's take a look at a typical web API call. So a user is going to request a route via their URL. That then calls into ASP.NET, which then maps that route to an endpoint, right? Some sort of class or some sort of method that it's going to then perform. Now, I prefer using a view model class to actually go out and hit my data store and get the data back. We then take maybe the view and the layout and make some HTML to send back if we're doing a web application, or we may just build some JSON or XML out of the data that comes back from our data store and send that back to the user. So it kind of depends on whether we're running a web application or a web API application. We will take a look at dependency injection in this course, and what this is it's a design pattern for passing an object to another object automatically. Now this is just built in to ASP.NET. We declare a class or a set of classes that we wish to be injected, and .NET will create an instance of these classes when they're requested and pass them on to the constructor of a class or maybe into a method if either one of those is requesting a class of that type. Middleware is also a very important concept in web servers. Each middleware class can be inserted into what's called the ASP.NET pipeline. Now, the pipeline is simply a set of classes that get executed in a certain order depending on how they were added. Now, the class could contain a method or many methods, and they're called on every request. Now, if you've ever used HTTP handlers or HTTP modules from previous versions of .NET, this is just like those. Now, each method then that is called in part of this pipeline can add or modify the request. Each middleware class can pass execution to the next class, or it could even stop execution and short-circuit the rest of the pipeline. Here's an example of what happens. So a request comes in, and throughout this pipeline, we may have a class here that I've identified as middleware 1. It could modify the request, and it could just pass control on to the next one, or it could abort the request, modify the response, and send that back to the caller. But if it says pass control to the next, then the next middleware piece in the stack says, okay, great, I got the request. It can then choose what it needs to do. It can either abort or pass control to the next middleware piece, which can then finally just say, well, I'm going to modify the request somehow, but then I'm just going to call your code, whatever that code is. Your code can then do whatever it needs, and it can then send it back through this pipeline. And again, everybody has a chance then along the way to modify that response. Now, what's important when dealing with middleware is that the order in which you insert the middleware into that pipeline is important. For example, authentication must take place before authorization. Somebody has to log in before they know what they're allowed to do. Exception handling should come before all other middleware because the other middleware may have an exception that happens. An example of short-circuiting, which I mentioned, is if the user is not authenticated, well, the authentication class just stops the rest of the pipeline from executing. There's nothing they can do on that website. If a user is not authorized for a route, so they've been authenticated, but now they're not authorized for a particular route that they're trying to get to, well, then the authorization class stops the rest of the pipeline from executing because there's no reason to call that route, no reason to move on. They just send a response back that the user is not authorized. ASP.NET has a lot of built-in components. We don't have to build everything. They have middleware for authentication and authorization. They have for caching and compression, cookies, cores, developer exception handling and production exception handling, diagnostics, HTTP logging, routing, session state handling, and static file handling. Now, there are others as well, but these are the ones that you'll probably use most often. You'll use some of these when you're doing websites, and some of them when you're doing web APIs. Middleware has to be inserted in the correct order, and you must follow that order. So I've got a URL here that you can go out and take a look. It has a great overview of where middleware must go in this pipeline stack. Let's take a look at our first design pattern called Minimal Web API. Now, this allows us to create HTTP endpoints with minimal dependencies. That makes it a little bit easier to use than MVC Web API Controller model. There's no more coding by convention, which is what you have with MVC. Now, this eliminates controller classes as endpoints, so that's partly what helps make it easier to use. Minimal web APIs are good to use with maybe microservices, applications with few endpoints, files, and features. I typically use minimal web APIs when I don't need a full-featured application or if I'm developing a smaller web application. So let's take a look at some routes and endpoints that we might see in Minimal Web API. Now, as I mentioned, every route in a web API must have a unique address. And we do that by doing app.mapGet, and then we give it the route. So hello is one route, goodbye is another route. And then you see the little arrow syntax for the function that says I'm going to return a string hello world, whereas the other one is going to return a string goodbye everyone. You can also optionally pass parameters into the route as well. So here we do an app.mapGet. Our first parameter then is the route, comma, and then within the function parentheses, we pass a parameter. And then we can use that parameter in the function. So we would call the above URL there using this following one here, www.example.com/hello/John. One thing I mentioned was dependency injection. What this is we tell ASP.NET that we want to inject a class, in this case called AdventureWorks API Defaults. And we add this to the services collection. Once it's in that collection, ASP.NET knows that when you have a parameter of that type in a function, so in this case, app.mapGet, and look at that second parameter we're passing into the function, AdventureWorks API Defaults, it says, oh, well, no problem. I'll create an instance for you and pass it to your function automatically. That's really a neat feature. And we're going to see examples of this. I have a whole section just on dependency injection. Let's now take a look at the MVC design pattern. MVC stands for Model View Controller. It's a design pattern based on the inversion of control and separation of concerns design patterns. The model is simply a class that we use to access data, perform some business logic. The view portion, not used in Web API, is responsible for presenting the content to the user, usually in the form of an HTML page. The controller allows us to get data from the model and give it to the view, or in the case of a Web API, the caller. So controllers are just classes that provide the routes or the endpoints for APIs. If you look up there in the route attribute, we have API / and then in square brackets, controller. Controller means use the class name, but we don't include the controller portion. So here you see public class product controller. The route would be API / product. Now, route, in this case, when it's attached to a class like this, that attribute is usually a partial route name, unless you just have very plain basic methods like get, put, post, and delete, then that is the complete route. But you can add other ones as well, other methods that you add routes to, the route attribute, and that will then give you more routing after the product portion. The API controller attribute identifies the class as a controller, So the above route would be something like www.example.com/API/product. Now, as I mentioned, we can define the rest of the route by using a route attribute on a method. So if inside of that class we have a get and we put a route attribute on it that says get all, well, then we would call that with /API/product/get all. Otherwise, if you didn't have that route, the get would be the normal get, and it would retrieve all of the data, in this case, a list of products. Now, you're also allowed to pass parameters to routes. The way we do that in MVC is we have the route attribute. We put the route name in there, /, and then in the curly braces, we put our parameter name. And then we can have another / and another parameter if we want. We simply have the one here. So inside of our function declaration here, by category, we put int ID. So to call that route, it would be the /API/product/by category /1, and 1 would be placed into that ID parameter. Dependency injection works very similar in MVC and Minimal Web API. You create a class with some functionality, like the AdventureWorks API defaults you see here. You tell ASP.NET your intention to inject this class by adding that class to the services collection, and then that instance can be injected into a constructor or into a method. In this case, on our product controller, we have a constructor that we pass to it the AdventureWorks API defaults. Now, we're not creating an instance of this class. ASP.NET is. So ASP.NET looks at this first parameter and says, is that in my services collection? And it says it is, so it injects an instance for us. Now, don't worry, we've got a whole section just on dependency injection, and we're going to look at this in much more detail then. In this lesson, we talked about Web API and how it's a set of action methods that process and/or return data. HTTP status codes and verbs are important to Web API calls. ASP.NET has a lot of tools to help you build routes and endpoints. The Minimal API Design Pattern is great for smaller applications. The MVC Design Pattern is better for larger ones because it provides this really good separation of concerns. Coming up next, create a Web API project and test it using Swagger and Postman.